This is an update to my Raspberry Pi Pixel server software, which is now IoT ready. It's ready for the Internet of Things. So what do I mean by IoT ready? Well, the Pixel server has always been a web application, so in theory it could have been connected to the Internet, but it did not have any form of user authentication. I've therefore always recommended that it not be connected directly to the Internet, unless you're happy with anyone being able to change the colour of your NeoPixels. This is the same with many of my projects, but why? The reason is that the amount of effort and code required to make an application safe to use on the Internet is significant. So, where it didn't need Internet access, I've been having them effectively sandboxed on my local network. But for this, I've taken additional steps to add authentication. Also to perform some security threat analysis, and I've added security testing to add additional security. This is to help protect your project from those that would try and abuse it. Hackers, crackers, or script kiddies. This is a test system I'm running on, so it's a little different from the final system, and you'll see that this isn't encrypted. When this is connected to the Internet of Things, it does go through a reverse proxy, which provides TLS encryption. So now I've connected to the application, it prompts me to log on. And this is something I didn't have before, it would just always go straight in. I'm going to log in as the admin user here, which is going to show you the full functionality of what we can do. If you logged in as a standard user, then you'd get a very similar look and feel, but there wouldn't be this settings option here. And so through the interface you can do all the usual stuff as before, so you can create your own sequence and apply and set that running. Again, different sequences all work. But now if you click on your own username, you'll see that there is a profile. I've deliberately set this so that this can't be edited except by an admin, which has to be done through the settings, and that's just for simplicity purposes at the moment. It may be a feature that I'll add in future. The main thing a standard user can do is to change their own password. The admin user also has this settings button where you can define the parameters of the NeoPixels, and so this is good so you don't have to remember the different options. There are some tool tips to help suggest what sort of values you want to put in. And significantly, so there's a hash algorithm. As you can see on this one, I've set it up as SHA-256. By default, it's actually Argon2, which is a much more secure hash algorithm. However, if you're running a Pi 0, which is what this one is running on, then the Argon2 is really slow. So hence I've given the option of using SHA-256 instead. And it's a toss-up between performance and security. You can save those settings, and then I've added all the user admin capability. So here you can see there's a number of test users that have been created. You can go in and you can modify these as an admin. The user cannot, as I say, change them themselves. And they can delete the users, and also the admin also has the ability to change the user's password as well. So that's the main additional functionality. All the code to control the colours and the pixels is pretty much the same as it was before, and it's really just the admin ability that I've added now. So when I said there's a lot more code needed to make this IoT ready, then the amount of code needed is quite significant. Looking at the code as it was before I started adding the authentication, then it's approximately 1,600 lines of code. When I added the authentication and user management code, then that jumped to over 3,500 lines of code. And then when I also added additional tests, then that increased to over 5,100 lines of code. As you can see from this, it's significantly more than the amount of code that was originally required for the basic server. This is also just a very basic user admin functionality, and there's only limited testing at this point. In future, this is likely to increase even more, and this doesn't even look at the additional time that I've spent performing threat analysis to identify risks to the server. I've covered that in another video, and I'll leave the information on that in the description. So, a quick overview of how the authentication works. There's 3 levels of access. A guest user, which is normally only available on your local network. They can change the colours of the LEDs and the running sequence, but nothing else. Typically this is used for automation, and that's the reason I've kept this in. The standard user has to log in, but otherwise has a similar level as the guest user. But they can also change their own password. But as I mentioned before, they can't change their own profile at this moment. So that's a feature I'll probably add at some stage in the future. And then the admin user has all the privileges as the standard user, but can also add, remove and edit other users. There's no admin user by default. In fact, there's no user name or passwords set up on default when you install it. The reason for this is that default usernames and passwords are often used as a way of gaining access to unsecured systems. But instead, I've created a script called createadmin.py, and that can be run locally on the local machine to create an admin user, after which you can then administer the users as required. An important point is that passwords are never stored anywhere on the system as plain text. As I mentioned earlier, they're in Argon 2 or SHA-256. So when a user enters their password, it's converted into that hash and then stored in that hash format on the configuration file. As I said, the more secure algorithm is the Argon 2. But for performance reasons, I've given the option of using SHA-256 as well. One of the things I wanted to do was to have this working with home automation systems. I wanted to do this without the automation system needing to log in to authenticate. But I didn't want unauthorized people on the internet to be able to change the lights. So the way I've implemented this is by having a rules based on the network address. Depending upon the IP address or the address range, you can allow 3 different types of access. If you don't add it at all, then the default is none, and that does not allow any access, and that would prevent any kind of connection at all to log in or to change any of the sequences. The next level is network allow auth, and this would normally be your default for most networks. This allows someone to log into the system and to be able to alter the sequences, or to log in as an admin and then have full access. And then the third one is network allow always, and this means that you don't need any login and you go straight in as guest access. You can also log in using this if you needed additional privileges, such as to be able to log in as admin to administer the system, but if you don't click on login, then you'll still be able to change the sequences. And the changes I added would support what's known as the AAA security framework. This stands for Authentication, Authorization and Accounting. I won't go into much details here, as I've got an entire video on this on my other channel, Penguin Fortress. One thing to be aware of is that with the use of a username and password, I wanted to enforce the use of SSL/TLS encryption to ensure that that is not visible on the network. I've done this by configuring an NGINX reverse proxy, and using Let's Encrypt to provide the encryption key. This is an extra step that's required during the setup process, and it's included in the README file for you to see how this needs to be configured. To provide improved security, I've performed some threat analysis and application security testing. I've covered both of these in videos on my other channel, Penguin Fortress. I'll leave a link at the end of this video, or you can check the description for more details. With these steps in place, then it should now be okay to connect to the internet. There's still a risk, as there is with all systems, and that is something that will be managed over time through adding additional tests and updating the code as necessary. The final step is to open a route through my home network router to forward requests for port 443, which is the SSL TLS port, and port 80, which is the normal HTTP request, but whenever it gets a HTTP request on port 80, it will redirect to port 443. Hopefully this is useful. If you want to understand how this works in more detail, then the source code is included on GitHub, and I've already referenced other videos explaining how the security works. If you want to find out more, go into the description and there'll be a link to my webpage. Please subscribe to Penguin Tutor for more Maker Project videos, and also look at my other channel, Penguin Fortress, for videos related to cybersecurity and the security aspects I've included in this video. And here's some links to relevant videos on the cybersecurity considerations. Thanks for watching, and look forward to seeing you on a future video.